All right, good afternoon. My name is Sarah McDevitt, and I'm a program manager on the user experience team in Windows. I hope you're enjoying Build so far, and I hope you've had a chance to install Windows 8.1 Preview on the new Surface Pro and that new Acer tablet that you got and start to play with those new features. Those devices start to bring out my personal favorite combination of 8.1 and the new devices that are being built for Windows. And that is being able to have multiple apps side by side on a laptop or a tablet with a super crisp screen, really high DPI screen. I think that's one of the most awesome things about this combination of 8.1 and new hardware. And that, of course, is a combination of the new multitasking model in Windows 8.1, giving people a lot more flexibility about getting the content they want on screen, and the new high-resolution and new form factor devices that are being produced for Windows. So making this combination great depends on enabling our app developers and all of you to make your apps great within this system. So the goal here is that your apps are well crafted at any window size on Windows, on any screen or form factor, so that you can take advantage of the power of this multitasking model. Ultimately, well-crafted apps within this model are more likely to have people keeping them up on screen for more time, whether they're getting stuff done in your app or they're getting stuff done in another app and just monitoring content within your app. So we'll go over some of the concepts behind this model, some of the details to start moving you down that path, some of the design decisions that some apps have made so far, and we'll look at some of those examples. And afterwards, I'll be at the office hours in the big room along with some of my teammates, and we'd love to talk to you about your specific apps because everyone will have some unique decisions to make for this model. They're also doing a cool thing there, I think it's called Fast Track, where you can actually sign up for a half hour and get one-on-one attention with your app. So you saw some of this in the keynote. But let's look at how this works. So I'm looking at the Mail app. This is the new Mail app coming for 8.1. And I actually really do want to go to the World Cup next year. I don't know if we have any soccer fans in the audience. But so I want to go check out this schedule. Now, I typically don't want to lose the context of what I was doing when I launch another app from my current app. So IE opens side by side. And this is done by a feature called app-to-app protocol launching. And apps can define certain details about how they're launched in this way, like what size they prefer on launch, etc. But the reason I want to call it out here is because this is one way that people will be put into these multitasking side-by-side scenarios without even knowing it's there, without remembering even how to get into that state. And so people will get really used to this. And these apps don't have to share the screen exactly half and half. So I can drag this gutter to the right, drag it to the left to see more of that schedule, and these apps react and adapt to the window size. So as a user, I can put these at flexible sizes depending on the content I really want to use. So 2 apps on screen is great. I like that. But you can have 3 apps on screen. And with 3 apps on screen, or any combination here, these could be 2 modern apps, fully functional, side by side with a fully functional desktop. So none of this has limited functionality here. That desktop is fully functional. And I can have 4 apps on screen at once with Windows 8.1. And again, fully functional desktop side by side with modern apps. So going back to the World Cup, for example, I know that when the World Cup rolls around, I walk around my offices and I see a lot of people with a World Cup game up on one screen and work going on the other, and I'm sure they're being really productive. But what if I want to keep my eye on like 3 World Cup games at a time? I want to see what people are saying on Facebook and Twitter about it. I want to chat about it. I want to have my mail up. And, I definitely want to have something important looking like Excel in case my boss comes by. Definitely getting work done. Boom. Multiple monitors, multiple apps on multiple monitors, and you can run this all from your Surface Pro, which I'm doing here. That's the most giant picture there's ever been of me, so I'm going to go ahead and move on. But 2 to 4 apps on multiple screens at once. That's the power of multitasking with multiple monitors with 8.1. So there's a new size, a new minimum size that every app will find itself in Windows 8.1, and that's 500 pixels wide. So any app in 8.1 can be resized down to 500 pixels. And from there on up, it's no longer about view states, and it's not about precise window sizes. It's about fluid resize up from your minimum. So that means that your app can be put into this size, can be put into this size, or any full screen size on a variety of different screens, and that's all fluid resize of that gutter from 500 pixels and up. Now you see on the left there, that window is at 320 pixels. That is, of course, the size of SnapState in Windows 8. We've made this completely optional in 8.1. So it's no longer a store requirement in 8.1 that you support that narrow window size. But if you do have compelling scenarios for a narrow window size, then by all means opt into supporting this optional minimum. And it's just a property in the app manifest that allows you to do so. So by default, your app can be resized down to 500 pixels, and if you opt into this minimum, your app can be resized even further down to 320 pixels, but completely optional. So you can start to see the power of the multitasking model in Windows 8.1. And of course, the big question is, how can you make your apps well crafted at all these window sizes? Every app is different, and you will have some unique decisions to make based on the content of your particular apps. But we want to get started about some of the concepts and some of the ways of thinking about this kind of mind shift about window sizes as opposed to view states. So we wanted to simplify the overall system for app developers and remove some of those rails, like removing the requirement for SnapState in the store. So instead of multiple view states that you have to provide distinct layouts for, it's all about an adaptive layout for 500 pixels and up. So that's the number one thing to start with. Now there are some principles around this. First of all, down to 500 pixels, we want apps to have full functionality, complete functionality down to 500 pixels. This is because resize becomes very natural to the user. Moving that gutter back and forth, just 50 pixels here or there, becomes very natural and trivial and shouldn't be disruptive to the task at hand. So think about resizing a desktop app or a browser window. When you think about that, I mean, that's existed for a long time, right? And it doesn't change the content of what you're working on. So that's a big principle here. Of course, that means that your layouts need to be adaptive, and that means both adapting to horizontal space, which is the change that I've been talking about so far, but that also means adapting to vertical space. So as new screens get higher and higher resolutions, you're going to have a taller and taller window to reflow content in. The second reason is because of these. So these small tablets, when you got your small tablet, hopefully you've gotten a chance to install 8.1 Preview on it, did you hold it like this? Or did you hold it like this and kind of hold it in one hand? We find that a lot of people are holding the small tablets in one hand or in portrait orientation. So with the small form factor, you're often going to have a window that's taller than it is wide. So that's the second aspect of adaptive layouts. So the first thing that I would do, moving my Windows 8 app into this model, is I just want to see what my layout does, how it behaves in this new window model. So taking XAML as an example, I have some primary layout defined. And instead of working off of application view state, I still get the same window size changed event, but now it's all about the size of the window. So I want to make my logic about the width of the window that I have. So this, of course, is the default, but it's saying that anytime my window width is over 500 pixels, I'm applying that primary layout. I have a similar change in CSS. So instead of my media query being based off of the view state, I just want to base that off of size properties of the window, and then apply my layout styles based on that. So I want to look at a couple examples, some of the design decisions that some apps are making in Box. So first of all, adapting to horizontal space. If you are a horizontally panning app, you're somewhat used to this already and can really rely on horizontally panning down to 500 pixels. So let's look at the travel app. This is the Bing Travel app. If I swipe to the right here, it's just a horizontally panning app. And if I resize this app by dragging this into a side-by-side scenario, if I scroll, this is really just relying on horizontally panning. The layout really didn't change. And they just support down to the default 500 pixels, and that's a great experience for their app. Whoops. Another app style that we see a lot of is a multi-column app or multi-pane app. So like Mail, for example. And the decisions that you're making if you have that type of app is all about what columns or what content in my columns are meaningful for any window size. So the Mail app is a 3-column app, and you can see on the left there, that column has text labels, and that's kind of my folder navigation, my favorites navigation. When I resize this app, at this point, or at some point, they stuck with 3 columns, but that left column is now, it's no longer text, they just took it down to icons. And then they support kind of flyouts here for your navigation. But as I resize this down even further, Mail decided, well, it's no longer even valuable to have 3 columns on screen. So they switched to single column reading for email, and then they added navigation to get back to the rest of the content. And from here, they have a 2-column layout. So they have that left column as icons, and they have your list of inbox here. So that can happen at really any window size that makes sense for you. So if you take a look at your content, let's just take this example that you have a 3-column app, or you have 3 kind of side-by-side content spaces that are really important in your app. Let's say you figure out that each of those columns needs to be at least 200 pixels for them to be useful. Well, that means that you only want to show those 3 columns if you have a window that is 600 pixels or more. So for you, your code might be based on a width of 600 pixels or less in either XAML or CSS, and then you'd apply layout changes like moving to a 1 to 2 column layout, reducing one of those columns to icons if that's an option. That's what Mail did, and things like that. So it's not just about that 500 pixel width, it's about what size is most meaningful for your content, and what size do you need on screen to show your content. Another style of app, of course, is fixed aspect ratio, and we see this a lot with games. I'm not going to go too in-depth about games, because there's a lot of details there, and there's a games track. Their office hours booth is right next to ours as well in the big room. But what you're thinking about primarily for fixed aspect ratio content is shrinking and growing according to your window size. And you'll have letterboxing on the top and bottom, and you can control some things about how that looks. The other thing I want to point out about games is that I said resize should not be disruptive to the user. The one exception to that is for a live action game, you might want to pause when the user is going to resize. And you can do that by a couple ways. Well, when the gutter is dropped, that's when you get any window size changed event. But for a live action game, you might want to pause when the gutter is picked up, right? So there are APIs to support that. You can do that when you no longer have the foreground activation, for example. so that you can pause a game. But that's really the only kind of case where disruption is a good thing. So the other aspect to this is adapting to vertical space. And there are a couple methods that you could take here that a lot of apps take either one of or combine. The first is using list view and grid view controls, because those will reflow content for you and gives you a really nice solution for adapting your layout to taller windows. The second method is adding additional content. So you can imagine that Mail app is really easy to adapt to vertical screens because it's just lists of email coming in. You can just add more email. But this applies to a lot of apps. So anything with feeds, anything that's kind of a query result type of collection, it's pretty simple to add additional content to fill that space. A third method is changing the size of your content. So making content larger, and this is typically really useful with things in your app like thumbnails or tiles or images, spaces like that that are pretty easy to just expand a little bit and take a little more space. So again, looking at the travel app as an example, they use a combination of these methods and do a really nice job of filling out a taller vertical space. So not only do they use a list view here, this is their list of panorama images, and that reflows content for them really nicely, but the second thing they do is they change the size or the height of those images a little bit. And the way they do this is they let the list view reflow. They have a minimum size that they want those tiles or thumbnails to be, and they say how many rows of my minimum tile size fit on this screen. And then they'll have some, you'll have some remainder at the bottom, right? That's a little bit less than a full tile. And so they just expand each image just a little bit to fit that space more perfectly. So what if you do want to support the narrow window size? First, how do you decide if you do want to support that? Well, now that it's no longer required, you can start with designing for 500 pixels and up, really nail that experience, and then you can always add support for that 320 narrow window space later on. And now that apps update automatically, people will just receive that new support. So there are some scenarios where this narrow window size is really valuable. We recognize that it's not especially valuable for every single app out there, and that's why it's no longer a required state. But some of the scenarios where it's really cool for are things that I want to monitor on my screen while I'm doing other things. So email, of course, chat is always a canonical example. But things like news feeds, social media feeds, traffic, weather status, flights, sports scores, there's tons of things that I want to monitor while I'm getting my work done, while I'm doing something else. And those are great scenarios to opt into the narrow size. Another reason would just be if you have an awesome Windows 8 Snap layout and you want to continue to support that. That's a great reason to opt in. And the third reason would be if your content just really naturally fits in that window. So lists, for example. Email, of course, is a list. Reading list, grocery list, shopping cart. Those are all great scenarios where a user can just allow that window to take up a little bit of real estate on their screen so they can have a whole bunch of other content there. Now, from 500 pixels and up, functionality needs to be complete. But below that, it's okay for functionality to be somewhat limited. And that's similar design guidance to the Snap State in Windows 8. But make sure that the functionality in your narrow window size supports the primary reasons that you opted into that window size. So I mentioned you get started with this by overriding the minimum width property in the app manifest to 320 pixels. And then the particulars of the design guidance are pretty much the same as in Windows 8. So these values are on MSDN today. And it's all about reducing the size of the margins, reducing the size of the back button and the header text, and typically transitioning to a vertical-oriented app or vertically scrolling app. Now there's one big difference between Windows 8 Snap and the new narrow optional minimum in 8.1, and that is no more programmatic unsnap. So neither Windows 8 apps or 8.1 apps can use try unsnap in Windows 8.1. So that means that if a user needs more functionality or more content in your app, they are the ones to resize the window. And that's why it's so important to support your core scenarios at the narrow window size if you opt into that window size. So for Windows 8, when you move to 8, or when someone moves to 8.1 and you have not yet updated your Windows 8 app, your Windows 8 app will run in a compatibility mode. Your Windows 8 Snap State will run in a compatibility mode. So you won't lose your Snap layout the moment 8.1 is out before you update your app. But what will happen is the user can resize that window below 500 pixels anywhere in that range of 320 to 500. So the window could be put at 400 pixels, for example. But what we'll do is keep your Windows 8 Snap layout exactly at 320 pixels, since that's precisely what it was designed for. And we'll pillar box the sides to fill out that window. Now, once your app targets 8.1, it will be defaulted to just 500 pixels and up. So if you do nothing, the user won't be able to resize your app down below 500 pixels. But if your app chooses to support the minimum width of 320 pixels, then in that range below 500, your app will fill that window. So there'll be no pillar boxing for Windows 8.1 apps on 8.1. So again, just the kind of the little details to get you going in that direction. If I have a primary layout defined and now I have a narrow layout defined, instead of using application view state snapped, I'm using size properties of the window. All about the size of the window. So whenever the width is less than 500, I'm using my narrow layout. Otherwise, I'm using my primary layout. Same with in CSS. Instead of using the view state of snapped, my media query is based off the size properties of the window. So max width, whenever I'm under 500 pixels, I'm applying my narrow layout styles. Now, another key part of this is crafting controls. So your nav bars, your app bar, any custom controls that you have in your app, you want to make sure that those don't get eclipsed or have some strange layout going on when you change the window size. So we want to make sure that those controls are well crafted at any window size as well. Now, app frameworks do a lot of this for you. So taking app bars as an example, if you look at the top row there, that's kind of a typical full screen app bar. And resizing that down to 500 pixels, I didn't have to do anything there. So the app frameworks take care of reducing the space between buttons, reducing the size of the buttons, and removing the labels from the buttons to fit that smaller space. However, if you have a lot of commands on your app bar, or if you're supporting the narrower window size, you're going to want to produce a second app bar layout for those cases. And what that allows you to do is group related commands into flyouts, and it allows you to choose which secondary commands fall off. So for example, in the narrow window size, since you really want to support your core scenarios there, you want to make sure that your primary commands for those are on the app bar. Another example of crafting controls in this model, I'm going to use the Alarms app. This is the new Alarms app in 8.1. You can play with this on your preview installation. And Alarms, it's kind of dark up there, but it's a horizontally panning app if you have a lot of alarms laid out there. Sorry, just a fly. And the Alarms app has a content for alarms, timers, and stopwatches. So if you look at the top left corner there, that's their main navigation. But the Alarms app said, well, when this text is translated into certain languages, at a certain window size, it's eclipsed, and they always want to have that navigation available in the top left corner. So at a certain window size, they switched the control to a drop-down. And that's now their primary navigation control. And it's still horizontally panning. That's really the only change they had to make. Otherwise, it's pretty simple for them. They rely on horizontally panning. Now, the Alarms app also opted into the narrow 320 window size. And so you can see this looks very much like Snap Guidance, where they transition to a vertically oriented window and reduce the margins and things like that. So far, we've looked at a few examples. We've looked at the Travel app, which just relies on horizontally panning down to 500 pixels and takes the simplest design option there. We've looked at the Mail app, which makes some decisions about what content needs to be on screen for their columns. And then this Alarms app example. Another example I want to show is Search. So this is the new Search for Windows, and our Marilyn Monroe example, as usual. And Search is laid out as a couple of panes, or a bunch of panes, laid out horizontally. And within those panes, they have some pieces of content that they mostly list vertically. At some point, at some window size, Search transitions to a vertically oriented layout. And this didn't just happen at 500 pixels. This didn't just happen for the narrow window size. Search actually chose to transition from a horizontally oriented app layout to a vertically oriented app layout at the point where their window is narrower than its height. So effectively a portrait window. We found that this is a pretty natural transition point for a lot of apps. Of course, it depends on your content, definitely not all apps, but people using apps in these different window sizes, it often feels very natural to pan along the longest edge. So when you have a landscape window that's panning horizontally, when you have a portrait window that's panning vertically, and then that feels really natural. So now I'm talking about a portrait window on a landscape device, or a monitor that's still landscape. But I mentioned that it's really, really important to support portrait for these devices, and that's, of course, the device orientation of portrait. But now that you're operating based on the window size, and not based on view state, and not based on physical device orientation, these are effectively the same thing. So if you make design decisions for a window that is taller than it is wide, then you've effectively made decisions for both of these scenarios, and you can nail both scenarios with a single effort. So, I mean, you can imagine putting an app up side by side on my laptop and holding your small tablet next to it. Those windows look exactly the same. So, now that your code is operating over the size properties of the window, this is really easy to do with a single layout effort. So whenever my width is less than my height, I'm applying a portrait layout. And with CSS, you can actually, instead of using the view state of portrait, you're using this orientation property, which tells you whenever your window has a portrait size. So that brings me to these cool new devices that people want to buy with Windows and that are being produced for Windows, which is really exciting. And what to do for these. So Windows takes care of a lot of this for you. And these new screens are getting higher and higher resolutions, up to points where your eye can't distinguish single pixels. They're above 200, 240. They're getting above 300 dpi, which is really, really crisp. So Windows scales applications to make sure that the experiences that you design are consistent across a variety of screens. Windows ships on such a huge variety of screens that it's important that, of course, that we can do this. So we want your app layouts that you design for all these window sizes to be great on all these screens. So the top row here shows kind of the concept if we did no scaling. On the top left is a screen that doesn't scale, or scales at a baseline 100%. And there's some text and a button, a touch target. If we move those onto a higher DPI screen in the top right, each pixel is really, really small, and those UI elements shrink. And with the really high DPIs that screens are being produced at these days, the text would be unreadable, touch targets would be unusable. So we use scaling. So taking the same screen on the bottom left, moving those items to a higher DPI screen, for example, your Surface Pro. We scale applications and all UI elements up by some multiplier, in this case 140%, so that the difference you see between these two screens is not physical size, but is the clarity and the crispness that high DPI provides. So a lot of these concepts are the same from Windows 8. There are no new multipliers or scaling factors, as we call them, or scaling plateaus. There are no new ones to worry about. There's 100%, 140%, and 180%. So those are the three scale factors that we use to scale applications for high DPI screens. Now, your window height is another thing that stays the same. So you're guaranteed 768 pixels of window height for your app, and that's logical pixels. So even when scaling is involved, you are still guaranteed 768 pixels of your designed layout. Now, that holds true for these small tablets, too. So even down to a 7-inch screen size, it still has to have 768 vertical lines of resolution. So that means that UI on these small tablets can get small. They can be fairly dense screens. But if you follow our text size and touch target size guidance from Windows 8, your UI will be great on all of these screens. So because touch targets are so important for tablets, we like to talk about our touch target guidance. And so on the left there is a 40 pixel by 40 pixel touch target. This is really great to use for all of your normal kind of everyday usage, the controls that people really need to use all the time in your app. Make sure they're at least 40 pixels by 40 pixels. For large controls, this could be major navigation areas, or if I had a purchase button in my app, I would make sure that nobody's going to miss it. So 50 pixels by 50 pixels is a good one for controls that you want people to be able to hit sloppily. If you really can't fit something on screen, you really need to fit a touch target in there, 30 pixels by 30 pixels will still be touchable on all screens running Windows. But it's not the best for things that people need to hit all the time. Also, remember to put a little bit of padding in between your touch targets. We typically say 10 pixels, but this is to make up for a little bit of touch error when people go for those touch targets. Now, another thing I want to note about the minimum resolution that we require for all screens is you might be wondering why 500? Why is 500 pixels the magical number that we chose for default minimum size? Now, one reason is any screen running Windows has to be 1024 by 768. So with that 1024 requirement, that means that every single screen running Windows can fit two apps side by side at a really nice size. It doesn't have to be down to 320 pixels. Every single screen running Windows can fit at least two good-sized apps on screen. So that's kind of where that number comes from. Now, there are a couple things that you can do to make sure that every pixel that you put in your app is as crisp as any screen can display. The first thing to do is providing assets for all three scale factors. So you do this in the same way as you did in Windows 8. It's based off of a file naming convention in your app package, and you can either do file names for each asset or image that you're providing, different file names per scale factor, or you can do these folders per scale factor and just throw all your assets into those folders. Doing this right ensures that our resource loading technologies can load the right asset for your app at any time. And I say for any time because we do support dynamically loading resources if the scale factor changes on you. And that can happen because of the multi-monitor support. So now that we support modern apps on multiple screens at once. Of course, you can drag apps between those monitors, and the screens could be running at different scale factors. So take that Surface Pro that you got and plug it into a lot of typical desktop monitors, and your Surface Pro will be running at 140% scale factor. So everything, your apps will be scaled 140%, will be loading your 140% assets. And then if you drag an app from your Surface Pro onto that desktop monitor, the App Frameworks in Windows takes care of scaling your app to 100% now and reloading 100% assets. So it's important to provide those assets. And one specific note about the 140% scale factor, the Surface Pro scales at 140%, but there's also tons and tons of laptops and tablets scaling at 140%. So in order for your app to look as awesome as all the UI on those high DPI screens, provide those assets. Now there's a concern, of course, with doing that, which is you start providing all these high-resolution images, these files are getting bigger, and those get downloaded onto every device, including this one, which just uses 100% scaling, and all of a sudden you're using up all of this disk space. So the solution is resource packages for assets. So think of this just like language packs, where only the applicable package will be downloaded for a given device. Resource packages for assets means you can place the assets for each scale factor in resource packages, and then we'll only download the most applicable one. So for example, a Surface RT will just download the 100% asset package for your app, and therefore the disk space won't be taken up by a bunch of high-resolution, 180% scale factor files. Now there's another talk that's going into this I'll reference at the end of how you do this and some of the details around this for the multi-mon scenario that I mentioned, and I'll reference that talk at the end. Now finally, I want to show you the Visual Studio Windows simulator. So the fact that Windows supports this huge variety of screens means that you have this huge test matrix if you wanted to test every single piece of hardware. You now have 2 awesome pieces of new hardware to test on, but there's a big variety. So the Windows simulator enables you to do some of this. So I have VS 2013, the preview of the Express for Windows version. And the first thing, before I get into the simulator, I just want to show where that property is in the app manifest to switch from the default minimum width down to the optional minimum width of 320 pixels. So I'll do that. I'm just using an app that was basically the template, and I made a few tiny little changes just to start seeing what these new media queries look like. So I have 2 additional media queries in here. One for recognizing when my window is in a portrait orientation, and one for recognizing when I'm below 500 pixels, since I just opted into that narrow width. And of course, this is probably not what the content will look like. This is just a really simple background color change to make sure I'm even doing this right at all. So to run this in the simulator, instead of local machine in my debug options, I'm choosing the simulator, and then I'll go ahead and run. And as this loads up, basically what this is a remote desktop session into your local machine. So that's actually my start screen, that's me, that is what is on this machine right here. And if we give it a second, it will run this really simple app within the simulator. And there we go. So it loads up my app. Takes a few minutes. And what this will allow me to do is see what happens with my layout changes on all these different screens. So of course I can see that my little background color change gets applied at the right times. So if I take this window of my app and grab it and put it into a portrait window size, I can see that my background color changed. So I must have gotten something right about that media query. The other thing that's important to note by doing this is you don't have to adjust your layout while the gutter's being dragged. So you get that event when the gutter's dropped. So it's not like a continuous pixel by pixel resize that you have to react to. It's when that gutter's dropped, you have a new size to react to. I can also see that if I make this app really narrow, I got my other media query right, my background color changes. That's great. All right. But the cool thing about the simulator is testing a bunch of different screens. So if I look at this icon on the right, it says change resolution, and I can bring up a list of different resolutions to test. Most of this list was there in Visual Studio 2012 for Windows 8 with a couple additions. So first, the 7-inch and 7.5-inch screens that we added to this screen, or to this list, enables you to start testing small form factor sizes. The other thing to note about this list is it's obviously not exhaustive still, but what we wanted to do is give you a reasonable selection to cover different aspect ratios and different scale factors, because those are typically the things that will affect your app layout even more than necessarily screen size. So we added a little bit of information in this list from VS 2012 to VS 2013. So it tells you the aspect ratio that that screen resolution is, and it tells you the scale factor that that device would get by default. Now, aspect ratio is an important one to test some different options on, because typically we're looking at 16:9 screens, but there are a lot of 16:10 screens out there as well, and those actually mean that you have a little bit more vertical space to fill. 4:3 aspect ratio, that's a little bit new to Windows. It was supported, but now really with the small devices, you'll see a lot more 4:3 aspect ratio, and that's definitely a different feel for app layouts. So the other factor in here is the scale factor, and that's that percentage at the right. So either 100, 140, or 180. So I'd encourage you to test the 140 ones. There's a couple 100% options, and then I want to call out the 180% option in here to test that highest scale factor. Now the other one I want to call out in this list is the bottom one. So this is a 2560 by 1440 screen, and this is a really great option to test if you're reflowing content well in a taller vertical space. Now, my laptop screen can't fit 27 inches, but it's really not so much about the physical screen size, and as you can see, everything in there looks really small. Well, oops. But this gives you an accurate representation of how your app will lay out on that screen. So physical sizes might feel different, but this allows you to even test a 27-inch 2560 by 1440 monitor even if you're on your Surface Pro, because you can see any layout problems that you have, anything that would overlap, anything that's not reflowing well. You can still test that in the simulator on any screen. So if I switch this resolution back to one of these small ones, and the other thing to test with the simulator is portrait. So being able to hold these devices in portrait is really important. And I'm using one of the small tablets, so that'll be kind of an accurate experience. And I use these rotation buttons to switch the simulator into portrait mode. And as you can see, I didn't do anything about view state or device orientation. Just my Windows size media query changed my background accurately for a window size that is portrait. So that's the Windows simulator. So what should you definitely do for this new model? Design for 500 pixels and up. That's the #1 thing to start with. It's all about window size. It's all about adaptive layouts from 500 pixels and up. Provide assets at all 3 scale factors. Small tablets, regular sized tablets, laptops, these are all seeing higher and higher resolutions, and those assets are more and more important. And third, become friends with the Windows simulator. I use it all the time. It's easy. It's actually pretty fun to switch the screen resolutions around and see what your app will look like on them. so that when you go to a store and you see all these new tablets and all these new big all-in-one screens, you know your app experience is going to be great on those screens. Additionally, consider supporting down to that 320 pixel width. Consider if people would like that with your app's content. So again, for apps that do this, if you have a compelling scenario, people will be able to keep that your app up on screen for more time while they're doing other things, because it's just taking up a little bit of space, and they can monitor whatever content you're putting through that app. And finally, think about any other size, any other window size that's meaningful for the content in your app. So one to think about is that portrait window size, and that has the advantage of nailing this experience as well. But again, there could be some width, like 600 pixels, that you need to make layout changes at. And this can be different for every app. So definitely come talk to us at office hours. We want to talk to you about your specific apps, the content within your apps, so we can start to figure out how to move you down this path and what sizes you might need to pay attention to. And this is all so that you can leverage the power of the multitasking model and these really cool new screens. I mean, the ecosystem is really bought into all these cool new screens, new high resolutions, new form factors, and we want to make sure that your apps look great on all these options. So finally, I mentioned a lot of concepts here. Hopefully you have kind of the mind shift from view state to window size to start moving your apps down that path. And these are a couple other talks that I want to point you to. First is a design-centric talk, Designing and Building UI for Windows. And this will cover some of these design decisions that you might need to make. The next two is deep dives into a couple apps that are good examples of apps that thought about these concepts. And I showed alarms and mail briefly, and those will go deep into those. The next one is a really great talk about upgrading your apps from Windows 8 to 8.1. This is a really important talk, of course. And finally, I mentioned the resource packages for assets, and that's the talk that will give you those details. So finally, please come visit us at office hours, and we can talk about specific content within your app. I'll be there today and tomorrow, and a number of my teammates are there as well. And with that, I am done. If we have any questions, please feel free. Thank you. Hi.
Hi, thanks for the great talk. When developing apps for devices like Android and iOS, we've learned that it's important to test on all kinds of devices. So I'm just wondering what your experience or recommendation would be in terms of how many devices should you actually test on, and whereas, instead of relying on the simulator for every different size.
Sure. So the question is about, for iOS and Android, they've found that testing on a variety of different hardware has been really important, and how many screens and what sizes do we recommend? So first, using the simulator, we wanted to get good coverage in there of different scale factors, so I definitely recommend testing at least one screen at each scale factor, so 100%, 140, and 180. I also would recommend testing at least one of the small form factor device, because that's new. So any screen size between 7 and 9 inches is a good one to start looking at your UI on this new form factor. Other than that, I mean, it's kind of time-based on how many you can fit into your testing, but I would make sure, I think that probably equals about 4 or 5 that you make sure you test on. And from there, you can kind of go crazy, but I would say at least those. Yeah. Yep, you're good.
Hi, user experience question for you.
Yeah.
I love the addition of the multiple snap views. How are you determining the focus of the application to access charm controls like search, share, settings, etc.?
There are the question is, how do you know and access charm controls from wherever your app is on screen? Since you could be, with 4 apps on screen, you could be one of the middle ones, you could be on the left, you could be on the right. So there are APIs to support that. we can tell you, you can ask for whether you're on the left edge or the right edge or where you are in the layout. And I don't have the names of the APIs for you right now, but we can take that offline and find those exact ones. Sure. But yeah, yep, definitely APIs to support that.
Hi, in that same vein, right now, if share or search are invoked programmatically, it's a requirement that they be unsnapped and that ensure unsnap needs to be called first, or you'll run into problems. Now that ensure unsnapped is gone, what is the guidance for when share or search are invoked programmatically?
Sure. So the question is about invoking search or share, which in Windows 8 required that the app then be unsnapped. So now, actually, I believe, and I can double check with you, but for any app that's going to invoke a charm, you actually want to opt into the narrow size because like the picker and those experiences can or will support the 320 pixel size. So it won't force you to unsnap. You'll actually stay at your size, and you opt into that. Yeah.
Thank you.
Yep. Sorry?
Want me to answer the charm questions more
Oh, sure. Yeah, come on up.
Hi. Just specifically for the charms questions, the two of them. In Windows 8.1, the charms will work at any app size, and they will operate on the app that last had focus, so the app that the user last touched. So you can see that if you were to have apps side by side and you have the black gutter, there's a little gray bar which will indicate which app currently has focus, and then when you charm in, the charm will operate on the app that has focus. So here you see the mail app does, and now the travel app does.
Yeah, so he's talking about this little bar here. That's the visual representation of which app has focus, but of course your app will know, and then that's what the charms that get invoked will apply to. Yes. That's John, by the way. He's one of my teammates.
I just wanted to ask about scaling really quick.
Sure.
Why 180% rather than 200%?
Why 180? So the question is about scaling. Why 180% rather than 200%? So
This is specifically for for small high density displays.
Yeah, sure. So one of the things about the scale factor is we have kind of a grid-based system in Windows, and the scale factors are chosen to make sure that everything stays aligned and everything applies within that grid-based system. So 100, 140, 180 were chosen mostly based on that, and based on the hardware that we know is out there and kind of that we know is coming that really optimizes the modern scaling system for those screens. And certainly, if in the future, some crazy, amazing, crazy screens are produced that we don't even have these days, we'll consider higher resolution. So, like the desktop, for example, goes to 200%, but the desktop and modern scaling are slightly different. So we've taken a look at that, and 180 is definitely the best high-resolution scale factor to optimize the Windows scaling system.
And you can have those independently configured for desktop.
Correct,
200, yes. Metro 180.
Yep. The question is, can you have the modern scaling and the desktop scaling configured differently? And yes, those are totally separate.
Totally separate. Okay. And then you flashed by so quickly. What were the recommended resolutions and scaling for 7 and 7.5 inches?
Sure. I can show you that list again. So there are two in there. That's the 1920 by 1200 and a 1440 by 1080. Those are two good ones to test for the small form factor device. Also, this Acer that you got is 1280 by 800. That's another good one to test. What we wanted to do with this list is give you a good variety for that coverage. So it's definitely not exhaustive. This 1280 by 800 is another good one to test. But the nice thing about those two is not only are they good small device resolutions to test at, but they also scale at 140%. So you kind of killed two birds with one stone there. Yep.
I got another one for you.
Sure.
This one might be a little bit of a Hail Mary, but is it possible, if you're using a dual monitor system, to have an application snap beyond just a single monitor? So right now with my workflow, like on Photoshop or Adobe Suite, I like to have my working files in one screen and then all my palettes on another. Is that something that's supported with 8.1?
So the question is about modern apps being able to span multiple monitors. So no, modern apps can't be on two monitors at once. They're on one monitor or the other. But one cool feature of 8.1 is that apps can now have multiple windows of themselves. So like in IE, if you go in and right-click a tab, you can open in a new window. And so then you can have a window of IE on your screen on the left and a window of IE on your screen on the right. You can imagine for mail, you can have your inbox in one window and you can have a mail that you're actually typing in a totally separate window, and those can be on separate screens.
Great, thank you.
Yep. Yes?
Sorry if I missed it earlier, but so if you're designing something for, say, 500 pixels wide, and you want it to look different on a 27-inch screen versus a 7-inch screen, how would you design something that's a different experience for the same pixel width?
Okay, so the question is, if you're designing for 500 pixels wide or some pixel size, and you want your experience to be different on a small tablet versus a huge monitor, how do you do this? So, I'm not really sure the best answer to that, actually. There are ways to understand a little bit more about the device you're on. Typically, we find that for the use cases for a small tablet and a large monitor, if you design for pixel sizes and window sizes by pixels, you'll have a successful experience across the different variety of form factors. If you have a specific thing that I'm not thinking of, a specific experience that you want to have different on those two devices, definitely come talk to me. We can figure that out. Another thing, by the way, is even though you're designing just for window sizes, you do have some APIs like for games, for example, that want to understand where the sides are for thumb controls, for example. There are APIs to determine that. Was there one more question behind you?
So what will actually happen if I try to unsnap? Basically, if I have Windows 8 up on Windows 8.1 and I still try to unsnap?
Sorry, I didn't quite hear that. Repeat that.
What will actually happen on 8.1 if I have Windows 8 up, if I try to unsnap? The example is like,
yeah.
I believe there is a camera capture APIs, and basically I needed to call camera capture from snap mode, and camera capture was crashing in Windows 8 in snap mode, so it has to be unsnap at that point. So I was using, I believe, that try to unsnap API. What will happen if, without updating the app, I have it installed on the 8.1?
So the question is, for Windows 8 app on Windows 8.1, what happens if you try to use try unsnap, so programmatic unsnap? I believe it will be a no-op, actually. It's just not supported in 8.1. Yeah, if John is still...
Do you want me to answer that?
There's another teammate in the back here.
Hi, I'm Miran. I worked on the try and snap functionality. So try and snap in Windows 8 could also fail. That's why it was called try and snap. And so in Windows 8.1, we just make it always return failure. So there's no negative consequences to you calling that as long as you're properly handling that. Same as in Windows 8, in certain circumstances, you could have gotten a failure at that point, and so you can't always rely on try and snap working.
Thank you, Miran. Yep.
One more question. Is there any way to rearrange the UI as you're resizing the snap view? Like in web pages, how when you resize the window, they arrange their, I guess, different components?
Yes, the question is there any way to rearrange your layout even within the narrow size range, right? Is that the question?
As you're resizing, like responsive web design.
Oh, as you're resizing. So no, you get the events that your window size changed when the gutter is dropped. And I don't think there's a way to follow that gutter resize continuously.
Okay, thank you.
Yep, is there anything else? All right, thank you very much, and we'll see you at office hours.